Well, it's another opportunity where I would like to take this opportunity to welcome everybody, every student, every engineer, every scientist who is actual in the higher level, such as undergraduate level. I would like to take this opportunity to welcome you into our online programs and our online institution that's called the Tanzania Online Institute of Technology. So we have, right now we have our official YouTube channel that's called Tanzania Online Institute of Technology, and later on we'll be having the same contents in different platforms. So my name is Olenjolai. It's the first time to meet me. I'm very dedicated. I thank God who has given me a gift of teaching and a gift of being an engineer. Welcome into departments of higher engineering and scientific mathematics. In these departments, we are training engineering students about engineering mathematics and scientific students about scientific mathematics. So actually, we'll be teaching about applied mathematics. So it's very interesting departments. We have a number of courses or number of modules. And one of the modules that we are teaching is called the Advanced Engineering Mathematics, or in other departments or universities, institutions, and colleges, they call it Advanced Calculus. Today we are in the chapter 3 that's called the partial differential equation. In short, we call it PDE. And the lecture that we are going to discuss is lecture 3, homogeneous and non-homogeneous partial differential equation. Before I do the quick review about the previous lecture, I would like just to ask you to be engaged, be a serious student, have your exercise book, have your scientific calculator for some cases, have your pencil for drawings, because it will be drawings in PDE, and also have your pen and have a fresh mind and get connected with what we are going to learn today. I don't know everything about advanced engineering mathematics or advanced calculus. I know a small portion, but I have a responsibility to teach others about what we are going to learn or about what I know. Be a serious student and trust what are we going to teach you, because we are using the curriculum of Dar es Salaam Institute of Technology, or DIT, in order to teach you the concept of advanced engineering mathematics and advanced calculus. So I don't want to waste much of your time. In case you have a question, don't hesitate to ask in the comment sections on below the video that you are watching, and we'll try our level best to answer your questions as well as we can. So let us go into the class. How are you, students? I have some physical students. How are you, students? Are you happy to learn? Are you happy to learn advanced engineering mathematics? Okay, good. So let us do the quick review before we go. We dive into the lecture 3. So quick review of what we have learned in lecture 2. So in lecture 2, basically it has been the lecture has been titled as linear and the non-linear partial differential equation. That's the name of the concept or the name of the lecture. In this case, we define the meanings of linear partial differential equation, And we say that this is the partial, this is an equation which contains the dependency variable and the partial derivatives, which has a power of first degree or first power. So then I taught you the definitions of non-linear partial differential equation. After that, then I taught you about 3 conditions that we are using to make decisions. 3 conditions that we use to make conditions or decide that whether the given partial differential equations is linear or the given partial differential equations is non-linear. So the first condition talks about dependent variable. For instance, u. If u present that in the differential equations has a power of 1, it's linear. But if u, let's say, as a dependent variable has power 2, it's non-linear. Then the next condition, which was actually discussing about the power of partial derivative. Let's say partial derivative of u with respect to t. If its power is 1, it's linear. But if the power of the second partial derivatives of u with respect to x with respect to t, it's, let's say 2, then it's non-linear. Again, the third condition, we discussed about the product between dependent variable and the partial derivatives. For instance, if you have something like this one, this is non-linear differential equation. But if the dependent variables is separated from, let's say that the partial derivatives like this, then we say that this is linear. So this is linear partial differential equation, this is non-linear. All in all, I left the homework, and homework I gave you 5 questions. I don't know if you have solved it and have gone through. In case that you have failed to solve any of the question, let me know in the comments in order to give you the solution. So that's all about what you have covered in lecture 2. If you have missed it, you can access in the playlist of partial differential equation and or in the place of advanced engineering mathematics or advanced calculus. So you can access. And right now, let us focus into today's lecture. So before I teach you about homogeneous and non-homogeneous partial differential equation, let me teach you the first concept, which is very important. And this concept, we call it the general linear. So you say that the general second order linear. When you talk about linear, you know, because I taught you in previous, the general second order linear partial differential equation. Okay? Before we learn about homogeneous and non-homogeneous. Class A homogeneous and non-homogeneous. So the general linear so we say that the general linear partial differential equation of second order in 2 independent variables, in two independent variables has the form of this one: a second partial derivatives of u with respect to x plus b second partial derivatives of u with respect to x with respect to y plus c second partial derivatives of u with respect to y square, then plus d, then have d, we have partial derivatives of u with respect to x, then you have a plus a partial derivatives of u with respect to y, then plus fu. This is equal to G. Separating. The general, say general. Say general. So the general linear partial differential equation of second order in two independent variables. In two independent variables has this general form. I said separating. A second partial derivatives of u with respect to x with respect to x. B second partial derivatives of u with respect to x with respect to y. C second partial derivatives of u with respect to y with respect to y. Plus D partial derivatives of u with respect to x. Plus E partial derivatives of u with respect to y. Plus Fu is equal to G. Right? This is the general. So listen, this is one of the form. The second form, the same general partial differential equation can be represented in this style, which is simplest. When I say separating, separating. Listen. Understand, then you write. So we start with A. A, this is the coefficient. This one we can write as U x x. Right? What does it mean? This xx is the one that we have denominator. Then plus coefficient b. Then this one we can write also as dependent variable u x y. Why? Because xy. Right? Then plus another coefficient c. Then this one we can write as u y y. Right? Then plus d. Then we have u subscript of x. Okay? Plus e as coefficient. Then you have u subscript of y. Plus f as a coefficient. Then dependent variable u. This is equal to g. So whether you write the general second order linear partial differential equation in this form or in this form, it's correct. Okay? We need to use this. Why am I teaching about the general second order linear partial differential equation? Because we'll be using this equation to state whether the given partial differential equation is homogeneous or non-homogeneous. Are we together? And after we cover homogeneous and non-homogeneous, we'll be solving examples. So we'll be solving questions, which actual, because homogeneous and non-homogeneous will be terminology number 8 and number 9. Clear? Right. So that is nothing. Kwa hiyo hii tunaita kwa lugha nyepesi ya Kiswahili ni kanuni ambayo ni ya oda ya pili ya equation ya jumla ya partial differential equation. Unaweza kaandika katika mfumo huu au unaweza kaandika katika mfumo huu. Na lazima ufahamu hiyo mifumo kwa sababu swali kwenye mtihani unaweza ukapewa katika mfumo huu au katika mfumo huu. Kwa hiyo lazima uzoee. Usije ukapenda tu kimbilia hii. Ukipewa hii unashindwa kuhama kuja hapa. Kumbuka hii unatakiwa kujua unahamaje kuja hapa na kutoka hapo unakujaje hapa. Sasa okay. After that, the next question that we have, what the meaning of A, B, C, D, E, F, G? A, B. So nasema kama tunaendelea na hiyo question, right? So let us continue that equation. Whereby A, where is A? This A. It can be a function. B, it can be a constant or function. C can be a constant or function. D can be a constant or function. E can be a constant or function. A and the O T and the F. So are the functions. He's in the functions and the function which depends. Depends or not? Depends on the two independent variables. Two independent variables. from this equation, mention the independent variables. Variables in this equation. Independent variables, quickly. X and Y, not XY. X and Y. Very good. Then mention dependent. U, the dependent. Sawa? Alafu X ndo independent. Manake X hazitegemea U, ila U inategemea X na Y. Are we together? So A, B, C, D, E, F and G zenyewe ni function ambazo zinategemea hizi independent variables mbili ambayo ni X and Y. Sasa kwa hizi ni function, manake inamaanisha nini? Kwa mfano, for example, A it can be, let's say, X squared. B it can be, let's say, cos of Y. Si unanielewa nachosema? C it can be, let's say, it's what it is, ln of X. Okay? D it can be, let's say, so this is examples of this function. D it can be what? D it can be 2x. Then even sometimes 2xy. Naweza kukuta hivyo. E it can be, let's say, what? 4, maybe constant 4. Then F it can be what? F it can be, let's say, log of x. Okay? G it can be, let's say, e power x squared. Ndio maana nazita ni function ambazo zinakuwa katika x na y. Hakuna u kwenye hizi a, b, c, d, e, f, g. Maana tumeelewana? Kwa utakavyokuta huko mbele, kwa sababu in the next lecture, lecture 4, I will teach you in detail about this equation, because this is the equation we are using to classify. Also, we are using to classify a partial differential equation, whether it is parabolic or elliptic or hyperbolic. So in the next lecture, we'll be discussing about this equation. This is the key. So lecture 4 and lecture 5, we'll be discussing about this one in detail. Are we together? So this is just an example, and they can be in this form, just to remind you. Are we together? Okay. So then we say that a second order equation, with two independent variables, x and y, which does not obey the form of linear partial differential equation. When we say the form, is stop writing. So tell me the equation. A u of xx plus b u of what? Plus what? D what? C u of yy plus what? U of x plus e u of y plus f of u is equal to what? G. So any second order partial differential equation with two independent variables x and y which does not obey this form is non-linear. Sawa? Kwa hiyo partial differential equation yote ambayo haifuati mfumo huu, hiyo non-linear. Kwa sababu kumbuka hii the general second order linear partial is non-linear. So I say that it is non-linear partial differential equation. In this module, we'll be discussing about linear or the general second order linear partial differential equation. Is it clear? Have you written? Okay. So if that's the case, if you've understood about the general second order linear partial differential equation, now I can teach you about homogeneous and non-homogeneous partial differential equation. So this will be terminology number 8, which is called the homogeneous. Homogeneous partial differential equation. Say homogeneous partial differential equation. Stop writing. Then we have a question. What is mathematical definitions of homogeneous partial differential equation? What is it? So homogeneous partial differential equation is an equation so we say that a homogeneous, class A homogeneous. Class A homogeneous. So homogeneous partial differential equation is the second order linear partial differential equation which obey so it's a second order linear partial differential equation which obey the condition of general second order linear partial differential equation which obeys the conditions of general second order linear partial differential equation, which is G is equal to 0. So you say that a given partial differential equation, is said to be homogeneous. Said to be homogeneous if and only if the value of G, in the general second order linear partial differential equation is 0.
If it's not 0, no.
Yeah, it's non-homogeneous. Simple like that. So recall what? Recall the second order linear partial differential. Recall the general second order linear partial differential equation, right? Stop writing. So tell me, A. A. Partial derivatives of U with respect to x plus what? B. Partial derivatives, second partial derivatives of U with respect to x, respect to y. Plus what? Say it. C. Second partial derivatives of U with respect to y. Plus what? Plus what? Plus what? F. This is equal to what? G. So it is homogeneous if G is equal to 0. That's the condition. Okay, so after learning the meaning of homogeneous partial differential equation, now let us learn examples. So this one in lecture 2 we ended example 8. So this is example 9. State if the given partial differential equation is homogeneous. Homogeneous partial differential equation. So state. So we've been given x, second partial derivative of u with respect to x, plus ln of x, partial derivative of u with respect to y, plus e power x, then second derivative of u with respect to y, plus 4x u minus x cubed, then second partial derivative of u with respect to x with respect to y. This one is equal to 0. So first of all, separating. First of all, is this linear or non-linear partial differential equation? It's linear. Why it's linear? Because to obey the linear partial. So the first thing, because you cannot just make it aside. We say recall the general second order linear partial differential equation. Separating, where is it? So you have to recall in this form. Okay? And you have to write in standard form. A second derivatives of u with respect to x squared plus b second derivatives of u with respect to x with respect to y plus c. You don't remember partial derivatives of u, partial derivatives of y plus d partial derivatives of u with respect to x. You don't remember e partial derivatives of u, partial derivatives of y plus fu is equal to g. So suppose that this is equation 1 and suppose that this is equation 2.
Let me ask you, if you interchange at d, write du over dx over dy, and then at d you write ae to b. Did you listen?
I didn't get your question. If you exchange it b and c.
At d and e.
D and E.
Yes, you interchange it.
It means, let's say you write D here and write E here. No, it's not acceptable. Yeah, because this is another partial derivative and this is another partial derivative.
So we're going to write du over dx, we write du over dy, then the second E, we write du over dx.
Are you asking about this term and this term?
Yes. No.
This one? This one and this?
I mean, yes.
Huh? This is second order and this is the first order. They are not the same.
D and E.
D and E? Yes, D and E? Yes, these are the first derivative, but they are not the same. This is the partial derivative of u with respect to x. And this is the partial derivative of u with respect to y. So, the first letter start with partial derivative with respect to x. The second ones, or the next one will be partial derivative of u with respect to y. Kwa hiyo usibadilishe hizi, sawa? Hii may be differentiated with respect to x wakati tumekeep y constant. Na hii u may be differentiated with respect to y wakati x may be kept constant. Kwa ni vitu viwili tofauti. Sawa? Okay. Okay, so then this is the first stage. Let us move into the second step. The second step, we say that write the given. So write the given partial differential equation. We simply call it equation 1. So write the given partial differential equation in form of general second order partial linear partial differential equation. What does it mean? Listen. This is the equation that we've been given. Arrange all the terms systematically according to this general second order linear partial differential equation. So how do we arrange? Find for this term first. Do we have this term? Yes, it's here. So we have x, second partial derivative of u, with respect to what? With respect to x squared. Right? Yes. Then the next one is b. The partial derivative is partial derivative of u with respect to y, respect to x, respect to y. Where is it? Do we have it? Yes, it's here. Right? So that will be our second term. So minus x cubic, second partial derivative of u with respect to x, with respect to y. Okay? Yes. The next term, Yavan, it's c, second derivative of u with respect to y. Find it. Is it there? Yes. Where is it? Yes. This one. Plus e power x. Then what? Second partial derivative of u with respect to what? To y squared. Okay? The next it is what? Plus d. Partial derivative of u, partial derivative of x. Look for it. Is it there? Huh? No. It's not there. So you say plus what? 0. Because it's not there. Okay? The next term, plus what? E. Partial derivative of u is respect to y. Do you have it? Yes. Where is it? This one. So plus what? Ln of x. Then partial derivative of u, partial derivative of y. Then the next term is what? Plus fu. Plus what? Fu. Do you have fu? Yes. What is it? 4xe. 4xe u. Then is equal. Is equal to what? G. Right? Do you have any value of g? Remember g, it does not have any u. What the value of g here? 0. So this one will be equation 3. Kwa hiyo tunachofanya kwenye hii hatua ya pili ni kwamba tunaandika partial differential equation ambayo tumepewa katika mfumo huu. Sababu huu ndo mwongozo. Sawa? Baada ya hapo, we go or we dive into the steady state. The steady state, we say that now compare what? Compare equation 2, the general second order partial derivative, and the equation 3. Okay? Huh? So if you compare, then we go. So what do you have here? A. So this coefficient and this coefficient will cancel. So simply A is equal to X. Do you agree? Do you agree? Do you agree? Yes. Then this coefficient, these partial derivatives will cancel with this one. Then B is equal to what? A negative X cubed. Okay? Then we compare the steady term with the steady term. Then we say C is equal to what? Do you understand? Yes. Next, we have to compare the first term, right? D partial derivative of U is respect to X, which is corresponding to what? D is equal to what? You forgot, 0. You don't have that term. Kwa term yote ambayo hatuna, tunaweka sifuri. Then we compare this one. We compare this one with this one. Compare this term with this term. Then, if that's the case, you say what? We say that E is equal to what? Ln of what? X. Okay? Okay. Plus FU. FU, we compare. We compare FU, we compare shorty with this one. Right? U and U will cancel. Then have what? F is equal to 4X. Then we compare on the right hand side, we have G. Right? G is compare shorty with 0. So that will make G is equal to what? 0. What the condition for the non-homogeneous, for the homogeneity? So then we go for the first state. So the first state, we say that the partial differential equation is said homogeneous. Homogeneous if the value of G is equal to 0. Is the value of G for this partial differential equation is equal to 0? Therefore, we say that the given partial differential equation is what? Homogeneous. You are done. Okay, so then let us solve the second example, and the second example for homogeneous, that is example 10. State if the given partial differential equation is homogeneous. So what the given partial differential equation is x squared plus y squared, and then this one is u of xx plus 3x u of y, then is equal to negative 7 u of x. Separating, let us solve. Separating. Solution. So solution, let us firstly recall what? So let us call this is equation 1. So x plus y square u of xx plus 3x u of y is equal to negative 7 u of x. Let this one to be equation 1. Okay? Okay? So this is the first step. The second step, we say that recall, or the first step. Okay, so we have not done just nothing. The first step, we say that recall what? Recall the general second order partial linear partial differential equation. So recall the general formula of second order linear partial differential equation. How do we recall? So we recall in this form, according to the form that we've been given in the question. So we say that A, I have mentioned, A u of x plus what? B A u x u I plus what? You don't mention the other one. U of plus what? Plus what? Plus what? Plus what? Is equal to what? So this is what? Okay? The second step after that, we say that let us write the given partial differential equation in form of the general second order partial differential, linear partial differential equation. Okay? How? Stop writing. You have to follow. Let us find this term. Do you have this term? Do you have this term in this given partial differential equation? Yes. Eh? Yes. So the form is what? The coefficient is x squared plus y squared u of xx plus. Do you have this term? No. So we have what? 0 plus. Do you have the same term? Plus 0. Do you have the first term? Yes. This one. We have to bring on this side negative 7ux will change and become plus 7ux. Okay? Okay? Then plus the next term, EUY. Do you have EUY? Yes. 3UY. Then the next term, FU. Do you have FU? No. The next term after FU, it's equal, is equal to G. Do you have G? 0. Why 0? If you bring this on this side, means if you add by negative 7ux to both sides, on this side you have 0. This one become what? Equation what? Equation what? So after that, we move into the, aha. Kazeni vidole jamani, kazeni mdo na kwenda. Okay, so let us now move into the third step. Stop writing. So the third step, after writing the given partial differential equations in the general formula of second order partial differential equation, then the third step we say that now let us compare the coefficient. So compare coefficients coefficients of what? Of equation 2 and the equation 3. So compare coefficients of equation 3, equation 2, this one, and equation 3. Stop writing. The first coefficient is A. A, UXX will cancel as UXX. A is equal to what? X squared plus y squared. The next one is what? B. B is equal to what? This is the preparation for lecture 4 because we'll discuss this equation in detail lecture 4. The next one is C. C is equal to what? 0. The next one is D. D is equal to what? A? 7. The next coefficient is what? E. E is equal to what? 0. 3x. Should you have it? Then the next term is F. F is equal to what? 0. Then the next term is G. G is equal to what? 0. So the first step, we say that the condition for the given partial differential equation to be homogeneous is if G is equal to 0. In that comparisons, is G equal to 0? Yes. So because G is 0, we say that it is homogeneous partial differential equation. That's all. Okay? Then after, I believe that you've understood the concepts of homogeneous partial differential equation. Isn't it? Then now, is that the case? Number 9, non-homogeneous. Non-homogeneous partial differential equation. Then the fundamental question, what is non-homogeneous? What is non-homogeneous partial differential equation? So simply say that a non-homogeneous partial differential equation is an equation in which the value of G in the given partial differential equation is not equal to 0. It's not equal to 0. So a partial differential equation is said it's non-linear, it's non-homogeneous if the value of G is not equal to 0. That's all. So from the general formula, and where that general formula is this one. So if the value of G is not equal to 0, that's non-homogeneous. Simple. If you understood homogeneous, then non-homogeneous, it's opposite. Okay? Pardon?
If it is equal to 0, that means it must be equal to a certain integer. If they may equal to, let's say it's equal to 7, we say minus 7 equal to 0. You can change it to see that homogeneous to be homogeneous. Is it?
I don't understand your question.
The question is it possible to change the non-homogeneous partial differential equation to be
How can you change? Here we do not change. These terms should be on this side according to the general form. We did not change. This is not G. You're allowed to bring terms on this side, you're allowed to bring some terms on the left hand side into right hand side. Okay? Yeah. So example 11. So state if the given partial differential equation is non-homogeneous. So this is our example. Stop writing. This is our example. State if the given partial differential equation is non-homogeneous. It's non-homogeneous. We'll be given that partial differential equation, solution. I said stop writing. So solution will be given something like this one. Let the given equation to be equation 1. Okay? Okay? Then the first step, recall the general formula of second order linear partial differential equation in this form. And let it as equation 2. Okay? Then after that, second step, write the given partial differential equation in the form of the general second order linear partial differential equation. So the question, example 11 look like example 10, but just the change. In example 10, we had u of x. Here we don't have it. So a minor change. So you are not supposed to claim. Maybe during your review, say, this question is like the one we discussed last time. No. We can do even the minor change. But for you can notice that they are similar. Okay? So if that's the case, you say that right in that form, we don't expect to have this term, so it will be 0. Okay, which term? It's what? D. Yes, A, B, C, D. For this equation, D is not there. Right? U of x. Then we have what? 3x. Okay, we have it. Plus what is 0? Well, plus 0 on the left hand side. Now we have a number which is -7. Are you together? Because remember G haina u yoyote. Kumbuka wengine wote ni coefficient. Ila G ni function ya x au y au constant number. Sawa? Tumeelewana? Elewa hiyo kitu. Kwa hiyo rahisi sana kuona G. Nasema hivi, hii ni coefficient ya partial derivative. B ni coefficient ya partial derivative ambayo ni second partial derivative respect to x respect to y. Hii C ni coefficient ya partial derivatives ya u with respect to y, Na hii ni coefficient ya partial derivatives ya u with respect to x. Na hii ni coefficient ya partial derivatives ya u with respect to nini? Y. Na hii ni coefficient ya u kama dependent variable. Ila G sio coefficient ya u wala partial derivative. Kwa ni rahisi sana kuona G. G inaweza ikawa number au inaweza ikawa x square au y square au x square plus y square. Maana yake inaweza ikawa number au function ya x au function ya y au number na function ya x na function ya y. Tumeelewana? Hutoona uu, hutoona mapasho pasho. Tuko wote mpaka hapa? Say this time, compare the coefficient of equation 2 and equation 1. A is still the same, right? B it is what there? 0. C it is 0. D it's what? A? E it is 3x. Is it true? A? F it is what? It is still 0. This one. Jamani, huyu na huyu. Huyu na huyu. Na huyu. Haya, huyu na huyu. Huyu na huyu. Huyu na huyu. Huyu na huyu. G is equal to what? Negative? Negative what? 7. Then the first is saying, the condition for the given partial differential equation to be what? Non-homogeneous. To be what? To be non-homogeneous. Right? Is what? G is equal to what? G is not equal to what? G is not equal to what? When G is equal to -7, is G equal to 0? Kwa G itakuwa thamani yote isipokuwa 0. G inaweza ikawa x square, inaweza ikawa 2x, inaweza ikawa ln ya x, inaweza ikawa e power x, inaweza ikawa e power y, inaweza ikawa log ya y. Kwa sikariri hesabu. So if that the case, you say that it is what? It's what class? No mambo anavyoenda hivi. It is non-homogeneous. It's non-homogeneous. Non-homogeneous partial differential equation. Are we together, class? So if that the case, I think it is enough. The dose is enough. Yeah, God's telling me that it's enough. We are going to end there, but let me leave you a homework. Stop writing. A homework is simple. This is homework 2. The homework is simple. Refer homework 1 in lecture 2. State if the given partial differential equations are either homogeneous or not homogeneous. So this is the homework. Sawa jamani? Kwa hiyo utapata hayo maswali hapa. Yaani ukishafika pale utapata maswali utaandika na itawafanya mfanye hiyo homework. Sababu jamaa akanipiga kidogo chenga. Okay, so if that the case, did you understand homogeneous and non-homogeneous partial differential equation? Is the concept clear? Did you get something? So make sure to review it several times so that you master it. I would like to say that this is the end of lecture 3. Where actually we learned about general formula of second order partial differential equation, and then we learned about homogeneous partial differential equation, and also we learned about non-homogeneous partial differential equation. So in the questions of the exams, you will be asked to state independent variable, dependent variable, dimension of partial differential equation, order of partial differential equation, degree of partial differential equation, and also what? Linear partial differential equation, non-linear, homogeneous, and non-homogeneous. So let's say that this is the end of lecture 3. Welcome in lecture 4, where I will teach you about classification of the partial differential equation. I will teach you how I can classify a partial differential equations as elliptic, as hyperbolic, and as parabolic. Don't miss that lecture. It's very important. It has been asked in test 1, test 2 previous years, and it has been asked in supplementary exams and even in final exams, and it's not a difficulty concept. We'll be having 2 lectures about classification, and then after that we'll go on solving heat equation. We'll start with wave equation, then we'll be solving the heat equation. I would like to ask you to invite some other students of BNG 23, BNG 24, BNG 25, 26, 27, 28, BNG 29, BNG 30, who are pursuing bachelor degree at Dar es Salaam Institute of Technology in any of the departments in the 60 departments. This is Olenjolai. My telephone number for more communications or for more, in case you want to communicate with me, 0759-745331. This is the very important phone number. You may call me in case that you need more help in higher engineering and scientific mathematics. I want to tell you that engineering mathematics, it's the queen of engineering. And engineering mathematics, it's beautiful. You maybe possibly you hate it because you didn't have good teachers who have taught you and actually encouraged you and reminded you about your ability on mathematics. I would like to ask you also just to be a serious student, register free into our official YouTube channel by just clicking the buttons that written subscribe on our official YouTube channel that's called Tanzania Online Institute of Technology. In case you have a question, don't hesitate to ask in the comment section and share these contents with others, and like or dislike the videos in order to have your feedback and give us feedback if you have understood or you did not understand. Remember to visit the playlist of partial differential equation, and remember to visit the playlist of advanced engineering mathematics or the playlist of advanced calculus, and remember to visit the playlist of gamma and beta function. So let's say that this is the end of this lecture. May God bless you and see you in the next lecture. Bye-bye. Wabariki